Welcome, everyone. I'm so excited for this event. My name is Sarah Gallagher. I'm the director of the Institute for Earth and Space Exploration here at Western, and this is our first joint event that we're hosting with McIntosh Gallery. Before we get started, I want to make the acknowledgement of the land. We are very fortunate to be in this beautiful place, which is the traditional territory of the Anishinaabeg, Haudenosaunee, Lenapehoik, and Chinookan nations. And this is a place that I consider home. And I think it's incumbent on all of us to think about the land and what it means, to pay attention to it, to look at the animals and think about the seasons, and realize that we are responsible to be caretakers of this land. And I think the Institute for Earth and Space Exploration, we actually have a lot of opportunities to be caretakers, to use the tools that we employ, Earth observations and instruments, in order to look after that land, both locally and around the world. I think that there are a lot of things that we can learn from the Indigenous peoples who have been on this land before and continue to be on this land. And one of the things that I think is really relevant when we talk about space is thinking about the agreements and the promises that were made between peoples to look after the land. So the Dish with One Spoon Covenant Wampum was a promise and an agreement made by peoples of the Great Lakes to look after the land and to share it. And I think we, particularly when we think about space, is something we also need to think about. Space is the commons that all of us around the world have to share. It is a finite resource and it is precious, and it is our responsibility to look after it. And I also think that thinking about what we can learn from the people who've been on this land for generations and from each other is also a beautiful model for this collaboration right now that we've done with McIntosh Gallery. A lot of us are scientists and engineers. We also have members of the Institute from all of the different faculties, but this is really our first collaboration with the humanities, and I'm very excited about it. And I would like to hand over the mic to Helen Gregory to give her perspective on this event.
Thank you, Sarah. I would like to start by thanking Sarah Gallagher, Catherine Neish, and Courtney Swindon for enthusiastically agreeing to partner on and largely coordinate this interdisciplinary panel that coincides with McIntosh Gallery's current exhibition, The Life Cycle of Celestial Objects, Parts 1 and 2. With a space-themed exhibition in a gallery located immediately adjacent to the Physics and Astronomy building, a potential collaboration felt like too good an opportunity to pass up. The life cycle of celestial objects is in itself a collaboration. It consists of two thematically linked projects that consider the implications of space exploration from several perspectives. The exhibition has its origins in an invitation from McIntosh Gallery to be named as a potential collaborator on a SSHRC NFRF grant that Joel Ong, professor of computational arts at York, was working on with Regina Lee, director of York University's Nanosatellite Lab. When the grant application proved successful, I suggested that we follow through and collaborate on an exhibition. Joel, Regina, and a group of graduate students from York in engineering and media arts worked together to create a multimedia techno-scientific installation that explores what it might mean to develop a participatory model of space exploration. This mode of operating is common amongst the arts and humanities, but perhaps not as apparent in the science and engineering departments, and even less common in those that bridge the arts or incorporate artists and aesthetic considerations in their research. I curated a companion exhibition of work by contemporary Canadian artists who consider space exploration and its ramifications from gendered and racialized perspectives. For example, Montreal-based artist Bettina Forget addresses the importance of women's contributions to science by highlighting the lack of moon craters that are named after women. Inuk artist Jesse Tungalik has created a spectacular sealskin spacesuit. Through the use of sealskin, Tungalik challenges preconceived notions of Inuit art and prevailing misconceptions of the Inuit way of life in contemporary Canada. He asks, if a spacesuit was designed and made by Inuit people, what materials and technology would be used? What ideologies are mobilized by decolonizing the spacesuit and its materiality? Indigenous art collective Bush Gallery created a tanned deer hide drum called Sounds of the Earth that directly references the golden records carried by NASA's Voyager probes in 1977. The drum is profoundly connected to the Earth and its indigenous peoples. With the drumbeat regarded as the heartbeat of the Earth, Bush Gallery sees the drum as an alternative way to communicate beyond the bounds of the Earth. Brandon Vickard's Alouette, which you may have seen outside the gallery, portrays a satellite that appears to have fallen from the sky and landed in the middle of Western Campus. Vickard regards the crashed satellite as a modern-day Icarus and an allegory for our dependence on communications technology. So I encourage you all to come and see these works and more by visiting McIntosh Gallery. The exhibition runs until December 9th. So in closing, I also want to thank my colleagues in Arts and Humanities, Joshua Lambier, Jennifer Martin, and Greg D'Souza, who've made this panel available as a live stream for those who cannot join us in person.
Thank you so much, Helen. And absolutely, so for those of you, if you don't know, McIntosh Gallery is right there. And the exhibit is really fascinating. And I enjoyed it a lot, especially the contrast between the two different galleries is really fascinating. So please check it out. And it will be there until December 9th.
Yes.
Is that right? So you have an opportunity to do that. So now it is my great pleasure to introduce our moderator and Dr. Catherine Neish, who is a member of the Earth Sciences Department here at Western. She is a planetary scientist who has done lots of very cool things. She's an expert in synthetic aperture radar, and she is also the Associate Director of the Institute for Earth and Space Exploration, whose mandate is about training and professional development. As I mentioned, she's an expert in synthetic aperture radar of planets, of other planets, including Mercury, as well as Earth. And she is one of the co-investigators on the Dragonfly mission, which is one of the very exciting future planetary science missions, which will go to Titan. And so without further ado, I'm going to pass it off to Catherine to introduce the panelists.
Thank you, Sarah. Whoa, this is louder than that one. And welcome, everyone. It's really nice to see you all out this afternoon. So we're really excited to have 4 wonderful panelists with us today. To my right is Dr. John Moores, who is an associate professor at the Lausanne School of Engineering at York University, but also the science advisor to the president at the Canadian Space Agency. His expertise is in planetary science, space science, and science policy. Next to him is Dr. Pauline Barmby, who is a professor and chair of the Department of Physics and Astronomy here at Western. Her expertise is in astronomy and astrophysics, but she's also a published science fiction author. And next to her is Dr. Joshua Schuster, who is an associate professor in the Department of English and Writing Studies here at Western as well. His expertise is in American literature, environmental ideas, and extinctions. And then last but not least is Dr. Kim Tait, who is the senior curator at the Royal Ontario Museum. And she has expertise in planetary science, mineralogy, space sample curation, and science communications. And in particular, I think we'll be quizzing her a bit on the OSIRIS-REx mission, which recently brought back a piece of the asteroid Bennu. So to kick off this panel, which is called Bringing Space Back to Earth, I want to tell you why I'm interested in this subject. So I actually have an undergraduate degree in physics and astronomy, but I found myself getting a little disillusioned with how far away the stars were and how I'd never get a chance to touch them or see a sample from them. So in my later years of my degree, I actually made a conscious decision to switch to planetary science, because I figured if I ever wanted to physically interact with pieces of space, I would have to study the planets in our own solar system. And so I did that, and I haven't looked back since. And as we'll hear about today, we have pieces of other planets here on Earth. We're also able to go out using spacecraft to use robotic arms to probe the planets in our solar system. And as Sarah mentioned, I'm really excited to do that with the Dragonfly mission, which we're sending to Titan, Saturn's largest moon, in the mid-2030s. So we're really lucky here. We're in a golden age of planetary exploration in terms of bringing space back to Earth. So there's different ways, as we talked about bringing space back to Earth. We can collect samples, either through robotic or natural means, but we can also send spacecraft, like I said, to probe surfaces with robotic arms. So I want to start with Dr. Moores and ask him about his experiences using landed spacecraft to study other worlds. So what, in your mind, are the benefits of these so-called landed missions to other planets? Yeah.
Thanks. Well, thanks, Catherine. And just to give a little bit of context to my answer about landed missions, you mentioned that you wanted the ability to sort of be able to touch the places that you studied, and I think that's really fascinating because for me, I started out in a different area as well, over in engineering, and one of the big draws in engineering, especially space engineering, is the ability to physically touch hardware that's going to fly and be deployed into space. But for me, I found I was always more interested in the actual exploration as well. And I hated having to say goodbye to missions after the spacecraft was designed and delivered. So I always enjoyed the idea of being able to continue on and to actually see all these different places that we would visit. Now, my own experience, it's very strongly tilted towards these kinds of landed missions. I've worked with Spirit, with Huygens, with Phoenix, Mars Science Lab, better known as Curiosity, and with InSight. And for me, the big draw is always seeing just a new vista out there for the very first time. That's the most exciting part. And then you get to do some science with it after you've seen it. So the big benefit to me of having these landed missions is that you can really interact physically with the surface and the environment, and you can determine exactly what processes are important at that very local scale and exactly what kinds of materials are present there. So we'll have instruments that can sample, that can taste that soil, or sense the winds as they blow over a sensor. And that's something that is a very different experience than from orbit, where each pixel of an observation is really big and it combines together a bunch of different materials and a bunch of different processes. And it can be sometimes difficult to tease that apart. But when you put the two things together, you do something called ground truthing, and you get a really powerful result from that. You can validate what it is you're seeing from orbit, and then apply that better knowledge that you gain from having the landed mission there across the entire planet with a global data set. And that is just amazing to see. So let me turn it back to you, Catherine.
Sure. Thank you, John. And so we can use landed spacecraft, like you mentioned, Spirit, Opportunity, the Mars rovers, but we can also bring samples back to Earth and study them in the lab. And that's something that I think Dr. Tait is currently doing. So I wanted to ask her, why do you think it's important to study materials from space? And what are some considerations you have to take in mind when curating these very rare samples? I'm going to pass the mic down to you.
Thank you for that question. So yeah, I think it's very important to study things from space, but I think I'm speaking to the choir of this room. But it's our opportunity to study our solar system. I'm very lucky to take care of a collection of meteorites at the museum, and so we have little pieces of asteroids, pieces of the moon, pieces of Mars that have been delivered here to Earth. And obviously we take very good care of them, and we make them available for researchers to study. And every time we look at a rock that we think, maybe this one, it's called an ordinary chondrite. There's gonna be nothing exciting about that. It says ordinary in the title. And every time we cut one open and make a thin section and start looking at it, it's very unique and very different. And there's something we learn every time that we open up each one of these rocks. And so, I think of our Earth, there's a lot of geologists in the room that I recognize, and we study our planet here, and we're given the tools in our undergraduate degree to study rocks from Earth. But what we're missing on our own planet is sort of that really beginning part of the Earth's history, right? If you look at the Earth's history as like a book, it's like we're missing the first 2 chapters, and that's where you set the plot and introduce all the different characters and all the setting up of all the big story that the book is about. And we can't look at those first couple chapters of our own story from the rocks on Earth, because they've either been transformed into new rocks or erased or reset. So rocks from space give us that very early information about our solar system. So if we study that, then we actually can learn a lot about our own planet and where we came from, and maybe answer that question of, how did life form? These are some really fundamental questions that I think everybody is very interested in. So I think it's very important to study space, and I think there's probably a lot of people in this room that would agree with me. But yeah, it's a very exciting time, because not only do we have the meteorites that have been delivered to Earth, we're actually getting materials brought back from certain missions like OSIRIS-REx just recently. I had the opportunity to go to Johnson Space Center and be there when it arrived. And there's going to be some really exciting times, I think, in the next little while as we start to look at these rocks and learn more and more. So there's missions being planned, missions to Mars, to other planets, bringing back materials. And I think it's just a really exciting time for planetary science.
Sorry, I'm going to do a lot of running around here.
Oh, no.
Thank you, Kim. So that's sort of the science introduction, but obviously we're here to talk about arts and humanities as well, and they can really help us to understand the discoveries we're making in the solar system and humanity's role in space. So the next questions I'm going to direct to our center two panelists, starting with Dr. Schuster. So you study literature, and from the perspective of literature, space can often act as a setting for a challenging environment. What do you think are the most interesting ways that space has been used in literature?
Okay, great, thanks. Thanks for having me on the panel, by the way. And I definitely feel like I'm here more like a fan, and among people who I really admire. And I'm often sort of peeking on everyone's projects and websites and just enjoying that. And actually, I think we share very much the same questions. Pushing the imagination, asking what is life, asking. What is the future of being human? How does space speak to those issues? And these we share in literature, philosophy, and there's a lot we have in common. But I'll just even add, so from my side, I'm always fascinated by history of poetry. There's a long intersection between poetry and space exploration. Many astronauts, read poetry, wrote poetry. You're probably well aware of that. Carl Sagan was a big poetry fan. There's been many poems put into space, put onto satellites. But even let's go backwards. John Milton, the only name that he puts in Paradise Lost is Galileo, somebody he met in person. And people of his generation were fascinated by cosmology. I'll add just two other examples. John Keats compares reading Homer for the first time to discovering a planet. And he has in mind William Herschel's discovery of Uranus. So he puts that into a sonnet. And then the other example I'll just mention is the Dylan Thomas poem, Do Not Go Gentle Into That Good Night, which was heavily featured in the movie Interstellar. And the fascinating thing about that poem is it's basically repurposed into space exploration. So the good night becomes the universe. So there's great number of questions great number of intersections. There's even personally, maybe I'll say more about this in a little bit, but I'm interested in how actually, so SETI, Search for Extraterrestrial Intelligence, might think about, it's very devoted to linguistics, and one aspect of linguistics is poetics. So I'm interested in how there's some thinking about poetics that can help us understand SETI and vice versa, how SETI might help us understand poetics. Maybe I'll get back to that in a little bit.
Thank you. And so the next question is to Dr. Barmby, who in addition to being an astronomer, as I said, is also a published science fiction author. So my question to you is, how do we as a society use science fiction to understand humanity's place in the universe? What's your take on that?
So I posed this question to a couple of my science fiction writer friends who know better than me. And a couple of their answers were, well, how could you understand humanity's place in the universe without science fiction? And one of them pointed out the idea that one of the things that science fiction gives you is a broader canvas to think about the universe, and to point out that maybe humans are not the main character in the story of the universe. And as Professor Schuster said, one of the points of literature is to think about what it means to be human. What does it mean to be alive and in a society, relating with other people? What science fiction gives you is another lens on those questions and a bigger canvas, a bigger place where those kinds of questions can play out, and a way to think about, well, not only what would my life be like if I had been born 80 years ago, but what would my life be like if I had been born on another planet? How can I get out of my own head and identify and understand with what it would be like to be different in some way? And so that shifting of perspective, I think, is one of the tools that science fiction gives us to think about our place where we are right now.
And as a follow-up to that question, so as a practicing astronomer, how do you think your scientific knowledge influences your writing?
So this one I had to come up with the answer with myself, because I don't have any friends who are practicing astronomers and science fiction writers, but that's okay. There's a couple of ways that I think it influences. One is it gives you material to talk about. There's lots of fiction about cowboys and soldiers and private detectives. There's not a lot of fiction about what it means to be a scientist. How do you look at the world? How do you deal with the world? That's not to say that all fiction about scientists is science fiction. Some of it is not, but lots of it is, right? Mary Shelley's Frankenstein is often given as one of the first examples of a science fiction novel, where, of course, it's what is it like to be the person who created the monster? I would say another way that my science gives me tools for my writing is as a source of metaphor. If you think about some of the things that we observe and experiment on and detect in astrophysics, the way that stars interact in a star cluster, or the very slow way that two galaxies interact with each other. There's some rich sources of metaphor for how humans relate to each other and how they interact with each other that people might not know about if that's not something that they spend a lot of time thinking about. So it's I read the archive every day, almost a couple times a week. And half the time when I'm reading them, I'm like writing story ideas down, because there is some turn of phrase, some metaphor, some intellectual construction that provides kind of raw material, a seed for things. And then I would say kind of the final way that my science influences my fiction is that when you know what the rules are, the rules of how the universe works, then you can be more deliberate about breaking them. and that's important for lots of creative arts, which are, even though people might not think of that, many of them are bound by rules and constraints, and so understanding what those constraints are is really important.
Thank you. Wonderful concepts to ponder. So Dr. Schuster mentioned that you were a fan amongst scientists, but we really appreciate hearing your perspective as a humanities scholar. It's not something we hear a lot in science, and that's a shame. We should do this more. But what new perspective do you bring to space activities and exploration as a humanities scholar?
Okay, well, thanks for the question. So first of all, I would say that actually there's no going into space without a sense of art and a sense of aesthetics. So everything one does, and I think there's an aesthetics embedded in it, and that's everything from design to like the collection of data and certainly images and so on. I would add though that I often think of, so I am fascinated by SETI in particular, and the science and sort of philosophy and art related to that. And I think, it would sort of be vice versa. So an extraterrestrial intelligence would also go into space with some sense of an aesthetic or an aesthetic interest. And just like we've sent art into space, they would send art into space. And what would that be? So I would suggest that, It's important to look for what we would call biosignatures. It's important to look for what we would call technosignatures. I would seriously also say it's important to look for something like an art signature out there. I don't know what that would be, but I'm curious, that's what science fiction is very much interested in. Then I would just building on this, I would suggest that, we've sent art into space, and then we've been doing that for generations. So like we have art about art that's gone into space. I mean, so like at the McIntosh Gallery, a lot of that art is sort of talking to other previous artists who've sort of thought about this problem or this issue. And so there's like generations of art sort of responding to previous generations about art in space. So there's conversations building in the art world. And so this isn't the first time. And so it's just an interesting thing to think about. Like there's artworks on satellites that are responding to like the Voyager satellites in different ways. And one of the things I think is fascinating about the Voyager is how it's so idealistic about human life and planet Earth. If you've seen what's on the Voyager records, all these hellos and all this beautiful music, and it does feel a little bit like that's not Earth anymore. Or does that represent Earth? And Carl Sagan, I remember, was saying like, well, we shouldn't send anything that's scary. But art, covers everything. And it should include, self-questioning about what does it mean to be human. It feels like maybe the wrong message to send. But I almost wonder if it's both the right and wrong message, because you want to have a nice greeting, a nice hello, and you would think in reality someone on the other side recognizes that. They know that your first hello isn't just who you are. So these artworks sort of keep telling those stories in different ways, and I think it's fascinating.
All right, thank you. So now we're going to switch gears and return to more of a science-based topic. And my next question goes to Dr. Moores. So let's conceptualize space from the public perspective. When we think about space, we think about maybe astronauts or the International Space Station. These are the things that are foremost in people's minds in the public oftentimes. But what are other ways that you see as the science advisor to the president of the CSA that space is being used on Earth?
Thanks for the question, Catherine. And even though I'm not here in my capacity as science advisor, I do need to give a big shout out. I know there's a lot of fans here in the audience and online about the astronaut assignment announcements that came out yesterday by Minister Champagne. So really lovely to see that. But going beyond the astronauts, and yes, things happen in space that are not astronaut related. There's a couple of different types of activities and a couple of different distinct sets of advantages, I think, that we get from those. So if you look at something like deep space exploration, you've got, so little mass, so little power, so little volume, and you're bringing back data through a straw. So you're always having to devise these really, really creative solutions to these kinds of problems. And you really need to know your technology, because you can't go out and fix it if it breaks. You need to figure out workarounds and stuff like that. And you know what they say about necessity being the mother of invention. You end up then with advances in technologies that find their way back to Earth and go into the things that we use every single day. So you've got that set of advantages. We also, thinking about astronauts just a little bit, unfortunately, the human machine is kind of fragile, and it needs to be fed, and it needs to be taken care of. So we can look at how to do healthcare in that kind of a setting, how we do food production in those sorts of remote settings. And we can bring that back for remote communities in Canada as well. So there's a second set of benefits, I think, that comes from that. But in sort of the deepest way, we also gain an incredible advantage when we take all these technologies, we turn those instruments around and point them back at the Earth to better understand our own home here. And that area is called Earth observation. So there's a few examples here. Canada is very good at this, by the way. And if you go to the space agency, the term of art is space utilization, in fact. So, we've got a number of wonderful Canadian satellites out there. There is SciSat that's been operating now for, almost 20 years, maybe even slightly more than 20 years, which keeps us informed about a number of greenhouse gases and other interesting things in the atmosphere. You've got MOPIT, which looks at carbon monoxide pollution in the troposphere, and that has a very long record as well, decades long. We've recently had a spacecraft called SWOT, which is Surface Water and Ocean Topography, and this spacecraft is just amazing. We were able to buy into it very cheaply, as it turns out, but what we get out of it is just incredible. It will revolutionize hydrology and how we understand flooding and how we understand how water moves on the Earth. And it does this by basically measuring every water body on the planet every week to a height of 1.8 centimeters. So we used to use tide gauges, or sorry, not tide gauges, but stream gauges and lake gauges to do this. And there was this Herculean effort to go out and put these in maybe 10 or 20,000 lakes in Canada. Well, Canada's got 2 million lakes, so you could never look at all of them, but now you can. For just an investment of $12.5 million, we see them all every single week. And it's amazing. I've seen the first data that's come out. It's even better than you can imagine. You can actually see the currents in the Great Lakes just by looking at how the height of the water changes. So having that kind of knowledge is just incredibly powerful. And coming up, we've got things like Wildfire Sat that'll actually be able to give first responders treating wildfires. And that's a bigger and bigger problem every year, as we noticed last summer. They'll be able to get real-time hotspot information every single morning. So that'll be amazing. We've got a set of satellites that'll be looking at high-altitude water ice and clouds and aerosols, which is one of the biggest missing pieces when it comes to climate change. So we'll be looking at that. And then, just because I love SWOT so much, I have to put in a little plug for the terrestrial snowmass mission, which is another potential future mission there, which is going to look at the other piece of the puzzle, all of that frozen water that then supplies the lakes and the rivers when it melts in the spring. So being able to get these kinds of data sets and to get them over the entire globe, where they're all cross-calibrated to each other in that kind of way is incredibly powerful. It gives us knowledge, it gives us a window into how our own Earth works and how to protect life and property, and really to plan for the future and build resilient communities. So it's amazing what space can do for Earth. It's not just the astronauts, though. Coming from the East Coast, the idea of a sealskin spacesuit is just fascinating.
Thank you. So Dr. Tait, you also interact with the public quite a bit since you work at a museum. When you interact with the public, what would you say their impressions are about space and space exploration?
Well, I think it's very positive. I would say that right away. Space is so easy to show and to get people excited about. You think about your own journey and when did you get excited about space? Perhaps it was when you were quite young, right? And you don't have to have a lot of knowledge. You just need to look up in the stars and start to, wonder what's going on up there and why is something more bright in some times of the year. Just start asking, those really basic questions. And I find that at the museum, we have a whole range of ages of people that will come, from really little kids all the way up to, senior citizens. And I think I look at my colleagues, for example, I have somebody that is an expert in leeches. That's a harder sell. Let's be honest. Not everybody loves leeches. I don't like leeches, and there's a display on leeches and people are like, okay, I'm gonna go over there, right? It's just not a sell. I would say space is a lot easier for people to love and to ask questions about. And I find that, we went to a school, Tim Haltigan and I at the CSA, we went to an elementary school and, I could see some of the little kids starting to kind of drift off. It was a 45-minute PowerPoint presentation. To be honest, that was a long time for a 4-year-old to sit still. So Tim was talking and I just went and sat on the ground and, passed around a piece of the moon, and before they don't understand, it's a rock, right? And I'm like, this is older than their mother. And they're like, oh. And then I'm like, it's actually older than the dinosaurs, and they're like, what? And then they start grabbing it and passing it around and stuff. It doesn't matter. We don't have to tell them, well, this is a North Acidic rock that, there's obviously very different levels, but even to get somebody to think, about how old something is, or how it feels, putting an iron meteorite in somebody's hands, and, they're like, wow. And, it's like, this is from a core of a planet that doesn't exist anymore. And, getting people to start thinking like that, it's very easy for people to get really excited about space very, very quickly. We had the opportunity to have Jeremy Hansen come to the museum a couple Fridays ago, and it was right before Halloween. And so I was a little worried that people wouldn't know that he was an astronaut, like maybe just dressed up as an astronaut. And so anyways, but we had people, like, the doors opened for, it's called Friday night, it's good activities. And it's more for sort of a younger crowd. And people were running through the museum to get up to the gallery to meet him. And there was a lineup, and there was, from little kids dressed up in spacesuits all the way to adults. And, everybody just wanted to have that interaction with an astronaut. So it's so easy to talk to people about space, and all different, from, again, a 2-year-old all the way up to, a 99-year-old. I think there's a very common fascination with space. You put Mars in somebody's hand, and it doesn't matter what CEO they are or what they've done in their lives or whatever, they get excited.
So I think I'm sold. Yeah, space. Space is the place to be. But I know not everyone, perhaps, is sold. So how do we convince everyone on Earth that this is exciting? So to Dr. Moores, why can't we just stay on Earth? What is it that we can't learn about the solar system, the universe, et cetera, if we only stay on Earth? Why do we need to bring space back to Earth?
Yeah, that is a really fantastic question, especially for those of us who are planetary scientists and who sort of love going out to do these things. And I think that what it comes down to in the end is the idea that some questions that we want to ask of other planets, things that we want to know, they require the types of tools and techniques, they require the kinds of instruments that are, in many cases, just too big to send to the planets. So we need to bring the planets back to the Earth. And if I can give you an example of that, some of the biggest discoveries that we've seen in the geosciences, just understanding our own planet in the last century, these have come from areas like stable isotope geochemistry. And in order to do that kind of work, you need rooms that are, or machines that are just enormous. They occupy whole rooms. They have these huge magnets to bend the trajectory of all of these different ions. And for some of these analyses, you even need equipment that could be the size of a building. So we've got the Canadian Light Source out in Saskatoon that can do some of these really critical analyses. So it's going to be much easier to bring a piece of another planet back to those machines than it is going to be to try to strap those onto a rocket and send them to the planets to keep them powered. But there's other factors as well. The planets are very far away places. It's really hard to interact with their surfaces and their environments from here. I mean, you can look at Mars, which is just covered with dust, and from a telescope on the Earth, you can't just brush the dust away. That's just not an accessory that comes with a telescope, unfortunately. So physics also limits the resolution of what you can do from a terrestrial telescope. There are things that are just too small to actually be seen. And I know this, from my own experience. I used to volunteer with the Alan Ives Carswell Observatory on the York University campus. And people would come in every Wednesday on our public observing night, and they would say, I want to see the footprints on the moon. Prove to me the Apollo astronauts were there. And you had to tell them, assuming that it was clear, they would ask this when it was cloudy too, by the way. But if it was clear, you'd have to tell them that, unfortunately, it's too small for us to be able to see with the kinds of telescopes that we have, just because of the physics. So that makes it hard. And it's also true that planets are worlds in and of themselves. They rotate, they go through seasons. There's always going to be part of the planet you can't see at any one time. There's illumination issues because the planets might not be illuminated in the way that you want to see in the places that you want to take a look at. In Venus, we never see, the full illuminated disk of the thing, unfortunately, because it's between us and the sun. So, that's the real problem. Once you want to ask these deeper questions, once you want to get below the surface, once you want to take a look at really trace gases in the atmosphere and things like this, you need to be there in order to make those kinds of measurements. Again, Telescopes don't come with a shovel. You may only need to get a few centimeters down to answer your scientific question, but you just can't do that unless you're there.
Thank you. So it sounds like we need a giant Mars vacuum cleaner then. Okay, that's our next mission. So I've heard many people on the panel today talk about how exciting it would be to find life on another planet. That's certainly something that motivates me, one of the reasons I became a planetary scientist. So my next question is directed to Dr. Barmby, and that is, if we do discover life in the solar system, say on Mars or in the subsurface of Europa or in an alien lake on Titan, how do you think that would influence humanity? And would it matter if it was, simple life forms like bacteria versus more advanced, intelligent life forms?
So, we know, I think, those of us in this room, how we would feel, right? Like Peter Brown would be setting off fireworks in the nuclear and stuff. Our lives would change forever in that, we'd go to conferences and we'd write papers and we'd think really hard and, it would be a big deal for a lot of us. Would it be a big deal for the rest of humanity? I actually think it would not. I think there would be an initial bump of excitement. I think there would be lots of news articles and people would say, "Ooh, that's cool." And then I think that the excitement would die away and people would go back to worrying about their daily concerns, about how they're going to pay their rent and who's going to win a hockey game and things like that. And I think that is likely to be the case regardless of whether it's microbial life in the solar system. It would be really surprising if we discovered that there were like bug-eyed monsters on Mars and they were going to come invade, right? But we know that's not going to happen. We know that life, if we find it nearby in the solar system, is not going to be the Star Trek Klingons who look just like us and speak English, but they have something on their foreheads. So life elsewhere in the solar system is not going to be something that affects people's daily lives, except in knowing it's there. And more advanced communicative life is presumably going to be further away in our own Milky Way galaxy. Again, chances are in our lifetimes that no one is going to show up at the door in a spacecraft and say, "Hello, we would like to offer you a timeshare on our planet," or something like that. So again, the concept is just going to be abstract for most people. Most people don't spend a lot of time thinking about how far away, Alpha Centauri is. It's not part of their daily life. And so I think people will go, cool, and then go on with their daily life. And I don't think that contradicts what Dr. Tait said earlier. I think there really is something to the physical. I can hold a piece of Mars in my hand that is different from, okay, you're showing me these squiggles that you say are a spectrum of some planet around some other star, and you're saying, holy smokes, look, that's molecule whatever. I think that's too abstract for people who are not the kind of people that us in this room are, which is not to say that there's anything wrong with people who are not like us, but we know we're the weird ones, as opposed to those people.
Thank you. So I think we've established that space is a pretty exciting field to be in, but it's not without its hazards. And I think this is something that Dr. Schuster has thought a little bit about. So I wanted to ask him, what do you think the risks of space exploration are? But on the flip side, are there risks to not exploring space? And how might the future of humanity be tied to space exploration?
Okay, well, so I'll just mention, I wrote 2 books recently on concepts of extinction and existential risk, and these are fields that do intersect a little bit with sort of planetary science, and existential risk is anything that might destroy humanity or destroy the planet, and that could include meteors, as well as unwelcome, unfriendly aliens. But there's a long tradition of people arguing that space exploration is necessary to at least reduce the risk of extinction, because if you're a single planet species and something goes wrong with your planet, you're not going to last long, maybe, and that's the lesson of the dinosaurs. But I think that's a big maybe, because I would argue that every extinction risk you face on Earth, you would face on any other planet. Okay, so if you're on Mars, the extinction risks don't go away, and in fact, you might have more of them for other reasons. So it's been a long argument that we have to go into space for that reason, sort of for almost like a species reason. But I'm not convinced. I think there's just as many risks for doing that. The other thing I would say is, to me, the other biggest risk is going into space with what I would say is like the wrong theory or the wrong motivation. And I mean, I certainly fear that. Over history, there haven't always been the most, let's say, beneficial or altruistic reasons to go into space. I mean, the United States was motivated to win the Cold War. Many countries go into space for nationalistic reasons. And that's not always the worst thing in the world, but there's tensions there. It's not necessarily to sort of share the Earth. And finally, the thing that we're seeing most happen today is people are going into space for, let's say, because they have the money to do so, or they want to make money to do so. So to me, those are not the right reasons to go into space. And the more people go into space, the more they reproduce those reasons. So I would be concerned about that. I mean, I don't think that that's the motivation for people in this room at all. And that like is deeply inspiring to me, and something I think about and learn about a lot. But on the other hand, I don't know if we have thought it through, enough for, let's say, the theories that we're carrying with us when we go out into space.
All right, thank you for those thoughts. So our last question of the panel is directed to Dr. Tait, and it's extremely open-ended, so go with this in whatever direction you want. But if NASA gave you billions of dollars and said, go design your favorite space mission, what space mission would you send and why?
This is a trick question.
It is not.
I feel like it is.
So be a grant.
Should I say, yeah, exactly. Is there any funders in the room? Tait? No. I don't know. What do you guys think? Where would you go? I'm kind of team Europa. I think
okay.
That's where I'd go. I think there's a lot of opportunity there for possibilities of life, water.
Did the mic turn off?
That's where I would go. Where would you guys go? Mars? Okay. Anywhere else?
Yeah, the mic turned off. I'm not sure what happened.
Oh, maybe the.
Where would you go? Where'd you go? Okay. Anywhere else?
I think Venus doesn't get enough love.
That's a good one.
Pun
That's a
intended.
good one. Okay. I don't know. That's billions of dollars. We have to all think about that and put our heads together, I think. But yeah, Europa. I'm gonna have to do it.
Okay.
I'll do what I can.
Okay. Thank you.
Thank you, John.
Slip that in.
And thank you, Kim.
Yeah.
So that wraps up our formal questions, and we'll go into some Q&A right now. But I just want to say something that came up while especially when Dr. Schuster was talking, was that famous quote from Carl Sagan's Contact, when the main character goes into space to discover these aliens and says, they should have sent a poet. And I think that says a lot, right? That we really do need to continue these conversations between humanities and science, because you can't really understand space without viewing it through the lens of an artist, of a poet, and bringing those two sides of humanity to the table. So thank you all for your thoughts today. I'm going to open it up to the floor now, and I'm happy to take questions for any of our panelists. So if you do have a question, please raise your hand. There's a microphone that somebody has. Does Helen still have it? Oh, Sarah has it. And so we'll bring that over to you for your question. So please don't be shy. Elisa, thank you. Yeah, the mic is for Zoom, not for the room, so do speak up.
It's
just for Zoom, so you need to project.
Okay. So loud, controversial question, not the one Courtney asked me to ask. But Mars sample return is billions of dollars. What is the public perception from your job, whichever job you choose to represent? What is the current public perception? It's like a multi-generational effort. What is the current public perception, and what is the future public perception going to be like?
Okay, yeah, so what in your mind is the public perception of Mars sample return, which is incredibly expensive? Anyone want to tackle that one first? Okay, Kim.
Bring it out.
You're probably the best one to start this off.
Well, that's a good question. And if Courtney put that in the crowd. I think as money gets tight and there's, people are having a hard time paying their rent and paying for food and everything, I think we start asking questions of why are we spending billions of dollars on science? I think that's like a fundamental question that people can ask. And, it was touched upon a little bit here on the panel. I think we have an answer. It's very important to understand our solar system, understand our planetary neighbors, understand where we fit into a bigger story than just, here in London, Ontario, or here in, the GTA or whatever. But I think the public perception as, wars go on and famines and people are dying, and we start to ask those questions as a community. And I think we have to always talk about the benefits of space exploration. If you look at every dollar that's spent on, I don't have these numbers, John probably has them better than I, but every dollar spent is $10 back into, we learned how to make Kevlar, for example, and for all the exploration that we were doing. I don't have those numbers on hand because I didn't know I was asked this question, but you can always try to defend and try to explain why this is important. But at the end of the day, these are hard decisions to make of how we're going to spend money. And I would certainly not want to be on a Senate floor trying to battle out these conversations. I am involved with Mars sample return, and we know that there has been a lot of questions even in the scientific community about spending so much money on one mission. Why are we spending billions on one planet when there's so much other things we can be doing? So it's going to be a question that's going to keep coming up, and I hope as a community we can at least agree that this is worthwhile. And then I think as a community we need to be then banding together and talking to the general public about how important this is to do. I've spent a lot of my career working on Mars sample return. I think it's very important, and I can't wait to have those rocks into labs. Again, we cannot strap synchrotrons onto rockets to go up to space. We need to get these rocks here. We look at Apollo mission, we're still making discoveries on rocks that were brought back 50 years ago, right? And that's going to keep going and going and going. So we need to get these rocks back into people's labs, but I'm preaching to the choir here. We need to, I think, do a better job of speaking to the public and making sure they understand how important the work that we're doing is to everybody.
Anyone else want to comment, or? Is there another question?
I have a question, but if we're still on this.
No, go ahead, Catherine.
Oh, okay. Different question. Is this actually work?
It's just for Zoom.
It's just for Zoom. You just need to project.
Okay. So this is for all panelists. What are some things that you believe that we could do to help avoid reproducing the mistakes that we've made on Earth and using space as a tool, or space exploration as a tool for bad rather than good? For example, when we've talked about the importance of Earth observation and how critical that is to understand things like climate change. Well, Earth observation is also used for militaristic purposes, for surveillance of populations, for surveillance of military movements, and we're seeing that happen in real time on the news every single day. We see that the companies that make the rockets that send our things into space also make the rockets that blow people up. So what are some things that we as space scientists can do to help change the way that we talk about space and change the way that we communicate to the world, and change, the way that the way that we do stuff? I know that's a pretty big question, so.
Yeah, so I heard, how do we not take our mistakes from Earth into space in any future endeavors? Yeah, so maybe that's, I don't know if anyone wants to, maybe one of our authors might want to tackle that one.
So for the students in the room, the answer is you need to take more classes. What I mean by that is that those of us with technical training often do not have very good training in the arts and humanities and the social sciences, in how societies change and evolve, until, in all the stupid things that humans have done in the past, because if you don't know about all those stupid things, you're likely to do them again. And that's really hard to think about when you're thinking about, but I already have enough partial differential equation homework. But, I think that's a really key issue. I think a lot of the problems that we see with some of today's space entrepreneurs have to do with the fact that they are technically trained, but that technical training has been overly narrow. And so I think thinking about how do we broaden people's training is really important. I will throw in a plug for science fiction, of course, with the idea that, science fiction is not just about robots and ray guns, right? It's about thinking about what if things were different? What if we didn't do things this way? And, lots of those things that people propose may not be very good ideas, but the point is to imagine a different future. And you're going to keep making the same mistakes if you don't think about how things could be different.
Sure. I would just, from my side of things, we're happy to have students in our class, sure. I always love having science students in the class just to hear their thoughts from their side of things. I do think that, in the arts, it's not like it's not a direct transmission of an ethical or more sensible, attitude, but we talk about these issues constantly, and sort of turning them into everyday problems, I think definitely is the right approach, as opposed to sort of bringing the ethics at the end kind of models, which I think it has been common over, in some situations in science. I think that my recommendation would be to sort of think about how something like care, collaboration, thinking about land, which Sarah Gallery mentioned, and generations and indigenous commitments and decolonization. These are embedded in every step of the process. They're not just some things that you add at the end. I think that, to me, collaboration in particular is such a key thing. You almost take it for granted in the sciences that you do that. But it's it's part of the machines. It's part of the science itself. And that is a good thing. The more of that happens, I think is the right sort of ethos. On the other hand, your question was specifically what about all these incredible technological things that can be used for good as well as for violence? I don't think we'll ever get away from that. I absolutely don't think that's going away. And just last point about this, I just think about artificial intelligence, which obviously will play a major role in science exploration and in every field, I'm sure. And the thing that I see there is that it is, absolutely sort of being modeled on things like capitalist, sort of we would call extractivism, sort of just accumulation of data or of resources and so on and so forth. And that's going to be embedded in the running of those programs. And I hope to not, I mean, to see more questions about that, and if that same mentality was embedded in sort of the science that we're doing and the robots and the space exploration we're doing, that I think that would be pretty disheartening, and we'd sort of be stuck with the same ideas we have over and over again.
So I think there's reason to maybe be a little optimistic. And the reason I say that is, if you look back to, the era of maritime exploration, science came last. There was planting the flag, there was economic interest, and then science was an afterthought. Whereas when we're going and exploring the planets right now, it is very much science-driven, science-based. Maybe there are, aspirations to get a first or things like that. But science is involved in the design and right from the very beginning. And when we're doing things collaboratively and openly, when we're talking about space as an area of cooperation, especially between governments and space agencies and companies and universities, I mean, that's a very hopeful model, I think. I do see some of the concerns that are out there right now. Like I look at, what some of the commercial actors are planning to do when I see, people go and dredge the Atlantic to pull up the Saturn boosters from the Apollo era. I just get very strong Indiana Jones vibes about how it belongs in a museum, right? So there is going to be that concern, I think. But the more that we can sort of tell that story, and as scientists learn how to communicate with the public and to tell the story of these places as they are, that gives us the best possible chance of turning them into just, canvases where we, paint, for future versions of our past mistakes.
Oh, can you pass it down to Kim?
This was such a good question. We all had to say something, but I do want to plug the Institute here. I think, what Sarah's doing here and getting people together that maybe wouldn't be in a room together, I think is a really good first step. We're in a panel here with people that probably wouldn't cross paths day to day, with museums, with very, very interesting colleagues that have some same interests. And I've got to meet through this institute, for example, people that study space law. And we had that discussion in my meteorite class, and that really got us thinking a little bit more broadly about not just getting rocks and not just going space and exploration, but who owns the moon? Can anybody just go? And and we started talking about the laws that are out there and how 50 years ago we never thought about an Elon Musk. What do you mean there's going to be a private citizen that is going to go and start taking resources from the moon? The laws were not written to cover that, right? So having people that are working collaboratively, not only university, but also, governments and industry and everybody working together for common good, and having those conversations early, just like John said, I think are really important. So I do really salute this organization here for what Sarah's doing with the Institute. She didn't pay me at all. I'm very, very impressed with what Western is doing here with having all these different groups together and putting together activities like this. I think it's a good first step.
Question in the back.
Thank you. So I just kind of bouncing off of the policy side of things that we were discussing, I wanted to hear the panel's thoughts on planetary protections. And specifically, there's kind of a small but loud section of the public that is very worried about going to these environments that might harbor life. And there are some people who would even say that it's not our place, that we shouldn't be contaminating these environments. Would you say that is more of an issue with the planetary protection policies themselves, they need to be stricter, or is it an issue with educating the public and making them aware of the policies that we already have in place?
All right, planetary protection. Anyone? John, maybe?
John, yeah.
Well, thank you very much for that question. I have to jump in here because I sit on COSPAR's planetary protection panel myself. And, I think what's out there is actually pretty stringent. You hear things like the European Space Agency saying that they're only going to send the ExoMars rover to a very confined area of Mars because it's just so difficult to actually satisfy the planetary protection requirements in what we call special regions. where there's water ice present and things like that. So, I think education is probably the biggest part of it. I would hate to see us not explore, but we do need to do it responsibly. We do need to make sure that we take the steps that are needed, not just to not contaminate these areas, but also if we're going there and we're looking for exciting science, we don't want to discover the life that we brought with us, right? Mm-hmm. We want to be able to make discoveries and measurements that we can have confidence in. And one of the lovely things with COSPAR is that they bring the scientists on board from all over the world to try and figure out the best way to do that. Anyone else?
Yeah. A question?
Sorry.
It's online?
Yeah, we have some questions from Zoom.
Okay. So there is a long history of science's role in art, but it seems that there is more pushback regarding the role of art in science. Is that your experience? And if so, do you think that this should change?
Good question. Excellent question. Maybe Dr. Schuster, do you want to? I'm just going to start assigning people.
Pushback meaning that there's too much science to do, there's not enough time to do art maybe, or something like that, or, yeah. I don't know, I don't have a simple, I don't have a simple answer. I mean, I'm definitely inspired just by the crossover potential. I think it was Dr. Barmby was talking about metaphors going back and forth. I hear the word remote sensing. I think that, that's what a poem does. Poem's a remote sensor. And it just helps me understand these better, or vice versa. I'm fascinated by how poems are, deliver messages over time to an unknown reader or an unknown addressee. They don't really know who's going to pick it up. And to me, that is the same paradigm as sending a message out into space. I don't know if there's, I can imagine there's tension in terms of, financial issues, but I think in terms of getting people to, be curious and to be more attentive, be more careful, be more, being able to sort of, again, have a better theory of what they're doing. I think you have to have a sense of the art stakes of what you're doing and the science stakes of what you're doing. There used to be an argument that there was two entirely separate disciplines, sciences and the arts. I think we're well beyond that. So I hope there's not I can't remember what the word was, but a sort of tension between these two fields.
The two solitudes, I think. No, that's English and French again. Never mind. So just to add a little bit to that, as Professor Schuster said, yeah, there used to be this idea that, well, art is creative and science is not. And that is nonsense. The science is an inherently creative process because we're trying to think up new questions and then we're trying to think up new ways to answer them. And that's not, I don't see how you can argue that that's uncreative. I think there's some other ways in which science and art necessarily have to cross over, because you can argue that, as Adam Savage from Mythbusters used to say, the only difference between science and messing around is writing it down. And he didn't say messing. And so communicating science is a big part of what we do, right? And I think we have a lot to learn from artists who specialize in communicating different things. Often they're trying to communicate an emotional response. We're trying to communicate an idea. But those things, there's things that we can learn on either side. And aesthetics is another aspect of that, where it's possible to make your scientific point using the ugliest plot known to humankind, but you probably generate more understanding if you think about how people perceive color and how people perceive shapes. Because ultimately, you're trying to communicate something to another human being. So again, I think there's room for art and science as well as vice versa.
And just really quickly, what I'd add to that is we often think about individuals exploring. You know, we talked about the astronauts and whatnot, but the reality of the matter is that it's not individuals that explore. It's cultures, it's society. It's something that we decide to do collectively together. And you know, as was said very well, you know, science is not separate from society. Science is not separate from culture. And if you try to pursue science that way, you're not doing it in a holistic way.
Another question online? All right.
So this is actually very cool. Bettina Forget has it.
Ah!
She's participated in the gallery, and I think that plays to be the last question.
Excellent.
For the panel.
Given that sci-fi and art in general offers a larger canvas for exploring scientific research questions, do any of the scientists on this panel collaborate with artists to bring some new ideas to their research?
Hi, Bettina. Thanks for the question. And we chatted actually a few weeks ago, and I think it's fantastic. We should definitely collaborate more with artists. But what do our panelists think? Anyone want to comment on that one, Kim?
Well, certainly, being at the ROM, I've been trying to do more of this. I don't think I was taught to cross barriers like this, and I think I've, in the last 5 years, as I start talking to my colleagues, and we have something called an ideation at the museum, and we come together and we bring out ideas. And I went to this many years ago with the idea of having a piece of Bennu on display for the people of Canada to see. And they're like, it's a black rock. Like, I don't understand why anybody would want to see that. And I'm like, because it's cool. I'm with my colleagues that are studying, South Asia, and then we started talking about it more and communicating more about it. And what the question that comes out of Bennu is, what is the origin of life? And if you start thinking about that in many different aspects, if you look at, different theological models of, how did we get here? There's so many commonalities amongst so many different disciplines that, if you look at, even indigenous cultures and talking about Turtle Island and talking about how, we got here, there's so many different stories, and really Bennu could just be sort of the end. It's like, this is just a rock, and but this tells a story from a scientific perspective. But if we talk about the origin of life from all these different other perspectives, maybe from from a Hindu perspective, or from a Christian perspective, and from all these different ways, then maybe we could find some commonalities and have some broader discussions. And so I think this ideation process has really started making me think a lot broader about some of the questions that I think about from my scientific perspective, that maybe we need to think broader. And we just hired, I don't even know if it's announced yet, we just found out yesterday that we're hiring a new Indigenous curator. And in the hiring process, I sat down with her and asked her questions about how does this interest you? And she was very interested. So I think that is going to be over the next 2 years. I have a fellowship where I'm going to be thinking a lot about some of these broader questions and trying to collaborate across with the arts to come up with some maybe new thinking about not only just science, but how do we talk to people that maybe aren't scientists a little bit more. So that's to be continued, but that's where some of my thinking is going, for sure.
All right, thank you. And thank you all for coming. With that, we're going to wrap up the panel. As you can see, there's some refreshments in the back, so please do help yourself. Please do introduce yourself to your colleagues. And just to wrap things up, let's give our panelists a warm welcome, and thank you for joining us today. And we'll talk to you all soon. So thank you, everyone.